A very warm good afternoon to one and all. Welcome to Little Flower College Guruvayoor for the webinar on statistics for planning and development. I am Alfie Jose, head of the department and assistant professor of mathematics. As we are celebrating today as the National Statistics Day, it's a pleasure and privilege to organize a webinar on the role of statistics in the current scenario. Statistics is a form of mathematical analysis that uses quantified models, representations, and synopses for a given set of experimental data. Statistics studies methodologies to gather, review, analyze, and draw conclusions from data, which is very much needed in the current situation of COVID-19. This day is celebrated as National Day in the memory of great Indian statistician Professor P.C. Mahalanobis, who is known as the father of Indian statistics. He was a member of Planning Commission and he gave the two-sector input-output model for the second five-year plan, which became the famous Nehru-Mahalanobis model of economic growth. He was honored with both national and international awards like Padma Vibhushan, Officer of the Order of British Empire, Fellow of the Royal Society, Weldon Memorial Prize, and many other fellowships. He founded the Indian Statistical Institute ISI. Also, on the occasion of his 125th birth anniversary on 29th June 2018, Indian Vice President Mr. M. Venkaiah Naidu released a commemorative coin at a program at ISI. The theme of this year's Statistics Day is Sustainable Development Goals. The theme has been chosen for intensive and focused discussions towards filling the data gaps and improvement of timelines or quality in sustainable development goals. And we are very much blessed to have one of the perfect and finest resource person to handle our session. Let me introduce the resource person, Dr. K. Jayakumar, Professor and Head of the Department of Statistics, University of Calicut. Sir completed his post-graduation and doctorate in Kerala University. He completed his postdoctoral fellowship in CUSAT, Dalhousie University, Canada, and Memorial University of Newfoundland. He received many awards and fellowships, including CSIR Senior Research Fellowship, NBHM Postdoctoral Research Fellowship, Jan Timbergen Award of International Statistical Institute, Netherlands, Best Research Paper Award in the papers published in ISI cited journals by King Saud University, Saudi Arabia, and many more. He has 31 years of research experience with his specialization in distribution theory, probability theory, time series analysis, and forecasting. He has more than 100 research publications, reviewed national, international peer-reviewed journals. He successfully supervised 10 PhDs and 6 MPhil theses. Also, he has served as the General Secretary and President of Kerala Statistical Association. On behalf of our college, I wholeheartedly welcome Dr. K. Jayakumar to this webinar. Leadership is about vision and responsibility, not power. Yes, our principal, Reverend Sister Dr. Valsa M.A., is the backbone of our college who responsibly lead us to excel and to be updated always, and in this special situation too. A perfectionist, a scholar, and above all, a strong believer of God. I welcome you, sister, to this auspicious occasion. Next, I would like to welcome each and every participant of this webinar who are eagerly waiting to refine their knowledge through the academic session. Also, I welcome my fellow colleagues whose constant support made this event possible. Once again, welcome all and thank you. I would like to welcome our principal, Reverend Sister Dr. Valsa M.A. for the presidential address. Sister, please.
Good afternoon. Greetings from Little Flower College, Guruvayoor. Hearty welcome to the resource person, Dr. K. Jayakumar, and the participants. First of all, I take this opportunity to congratulate our Mathematics and Statistics Department for conducting this type of a webinar. Today is the Statistical Day, National Statistics Day. So this day is very useful to talk about the statistical analysis and also which is very useful for development and planning in our country. Ms. Alfie Jose and also Ms. Mariama Anthony, these two persons took the leadership to conduct this seminar. I'm extremely happy to inaugurate this webinar. Let this opportunity a good, informative and useful one to each and every person to make their efforts in planning and also making development in our country. I wish a grand success for this webinar. Thank you. Thank you very much.
Thank you, sister, for those inspiring words. Let's start our academic session. I wish all the participants a great session ahead. I humbly request Dr. K. Jayakumar to begin his informative and enlightening presentation. Sir, please.
Good afternoon, all. At first, I wish to thank the college for organizing a webinar of this type on the occasion of the National Statistics Day, and also the efforts taken by the Department of Statistics and then Department of Mathematics, especially the head of the department, Alfie Jose, and the other colleagues are in fact very appreciative. So what I am talking here today is on the role of statistics for planning and development. So now let me directly go to the topic. So I may mainly concentrate on the role of statistics in planning and development. So why we are celebrating National Statistics Day? What are its importance in the current scenario, and how does it help in how does statistics help in nation building? So our topic of today's discussion is webinar is statistics for planning and development. So it is today is in fact the National Statistics Day. And National Statistics Day, as pointed out earlier, it is celebrated on 29th June in every year in India. And it is celebrated. What is the purpose of it? To create public awareness among people about the importance of statistics in daily life and in the process of planning and development. Why we have chosen 29th June? Because 29th June is in fact the birth anniversary of Professor P.C. Mahalanobis, who, as already told, is the father of Indian statistics. And the government of India has celebrating the Statistics Day. The aim of it is to popularize the use of statistics in everyday life and to sensitize public how to use statistics in framing the policies. And this day is organized by the MISP Ministry, that is Ministry of Statistics, Planning and Program Implementation. And apart from this, some of you are aware that the United Nations has taken an effort for celebrating what is known as the World Statistics Day. And World Statistics Day is celebrated on 28th October worldwide in every 5 years. And the National Statistics Day was first celebrated on 29th June 2007. National Statistics Day is celebrated usually by holding various types of seminars, discussions, competitions to highlight the importance of official statistics in the national development based on the themes of national importance. And so let me begin my talk by presenting some of the contributions of Professor P.C. Mahalanobis, and let me look for his life sketch. That is, he was born on 29th June 1983 in West Bengal. He was a scientist and an applied statistician, and as we have already told, he is the father of Indian statistics, and he is popularly known for what is known as the Mahalanobis distance, which is in fact usually used in very many areas of statistics, for example, classification and discrimination and so on. And also Felden-Mahalanobis model, and also he has made significant contributions in the design of large sample surveys that are essential for a country like us to get information. And also, he was a member of the planning commission. That is, he was in fact instrumental in developing and implementing what is known as the second 5-year plan. That is during 1956 to 61. And he has honored with several awards based on his contributions in various theoretical and applied fields, and he is basically a physicist turned statistician. And he was he was instrumental in founding what is known the Indian Statistical Institute in 1931, and also he has started a prestigious journal of statistics, which is the Samkhya, which is now well known among other journals in the field of statistics. And also based on his contributions, a lot of government of India has released a commemorative coin. And now let me look for the functioning of the Indian statistical system. Whether India has a statistics system, official statistics system? If it's so, how does it work? What are its roles and responsibilities? The Indian statistical system presently functions within an overall administrative framework of the country, and it has the main, that is the nodal agency for the agency instrumental for coordinating all the activities of statistics all over the country is the Ministry of Statistics and Program Implementation, and it works through the agencies, the CSO, the Central Statistical Organization, Sample Survey Organization, and it is the apex body that governs the statistical activity of the country. Some important functions of MOSP are to act as a nodal agency for planning and integrated development of the statistical system of the country. Coordination of the statistical system with a view to identifying gaps in data availability or duplication of statistical work in respect of different departments of Government of India and Statistical Bureau. And also it takes care of so many other activities in collection with data. And it is responsible for conducting large sample surveys, for creating database for studying impact of specific problems for the benefit of the society in diverse areas such as employment, consumer expenditure, housing conditions and environment, literacy levels, health and nutrition, family welfare, etc. You see that the Government of India regularly conducts surveys regarding all those things. So the health status of the individuals in the country, the employment status of the different types of qualified and skilled laborers and all that, and the expenditure pattern, and the housing conditions and environment, and the literacy levels among various individuals and so on. So these things are usually governed by or monitored by Ministry of Statistics and Program Implementation, and it is done through what is known as the Central Statistical Organization. That is, they organize and conduct periodic all-India economic census and follow-up enterprise surveys, ensure functioning of the Indian Statistical Institute. You can see that the Indian Statistical Institute, in fact, was established through an act in Parliament. So, and the functioning of it is now monitored by the the Ministry of Planning and Program Implementation. And also, MOSP is responsible for preparing national and regional accounts as well as publication of annual estimates of national product, government and private final consumer expenditure, capital formation, savings, and so on, and SDP. And also, the statistical system at the statistical system at the center that collects different types of statistics in specific areas such as agriculture, labor, commerce, industry, etc. And which is run by separate ministries. And the CSO, that is a part of the MOSP. MOSP in the Ministry of Statistics, Planning and Program Implementation is the nodal agency for the planned development of the statistical system in the country and for bringing about the coordination of statistical activities among statistical agencies in the Government of India and state directorates of economics and statistics. So it in fact coordinates the different activities. And the statistical systems in the states is similar to that at the center and generally decentralized with major departments such as agriculture or health having large number of statistical divisions in the department at state level. In the state level, the apex body is the Department of Economics and Statistics for collecting or coordinating various statistical activities in the state. And they publish statistical abstracts and handbook for the state's annual economic reviews and surveys, statistical abstracts, state budget analysis, work out the estimates of state SDP and retail price index numbers, and engage in other statistical activities relevant to the state. See, all these things, that is, all the things that are relevant to us are collected by some agencies, that is, in fact, that is collected and monitored through the Directorate of Economics and Statistics. Now let me go to the CSO. CSO was established in May 1951 and it's a responsibility I have already told. I do not go into the details of it. And also CSO imparts training in official statistics and it is in fact responsible for formulating 5-year plan relating to the development of statistics, the development of not simply statistics, development of activities in states and union territories, and also disseminating various statistical information, including relating to social and environmental statistics, undertaking periodic revision of national industrial classification. CSO is also responsible for periodically conducting conferences of central and state statistical organizations. Now, these are in fact the status of the official statistical system in India and in Kerala. So, now the next question is whether the statistics is so much needed for planning activities. So, what is its role in framing public policies? Is a statistical decision is needed for framing the public policies and government policies? So, I may just look for some of the important points to be discussed, to be noted in this regard. Suppose we want to estimate the poverty in India. So you can see that the poverty in India, how will you decide the base of the poverty line? How will you say that a person is above the poverty line or below the poverty line and so? How will you redefine it? You can see that in the 1956 year, the person below the poverty line may not be the same as the one in the 2020. So the poverty line, you have to redefine it according as the social status increases and so on. So how does you estimate that? How does you find? So let me begin from the very beginning. In 1971, Dundaker and Rath tried to undertake some exercise to decide the base of the poverty estimation. And they call what is the parameter they have taken to identify the poverty. They have taken the parameter as the minimum calorie needs of the rural and urban population. And based on this, they are trying to estimate the poverty. So those who have with less calorie, minimum calorie requirement is considered as poor. So this assessment, for this assessment, they required data which was provided by what is known as the National Sample Survey Organized. So you see, so for these type of these only, we as a country we know about what is the power, what is the status of its individuals. So regarding poverty, you know how to estimate. In order to estimate that, you need the data. And so here we could see that the role of statistical organizations like NSSO are closer to the reality for doing these types of surveys using statistical approach. And now, if you look for the agriculture sector, in our country, you can see that 70% of the population, the agriculture population, that is the farmers, depends upon rain for doing their agricultural activities because of the lack of irrigation facilities. If you have irrigation facilities, then you may not be, depend upon the raining pattern and all that. So you can see that in our country, approximately 70% of people will depend upon, the farmers depend upon the rain to see their crops at convenient times. So how will you say that you will get the amount, this amount of rain in Delhi in July 2020, this amount of rain in Rajasthan 2020, this amount of rain in Kerala 2020? How you may estimate that? If you can give an idea about to the farmers and it is closer to the reality, he may be able to do his agriculture work, like farming accordingly. So these things, how we can do it satisfactorily. So how you may be able to forecast the weather condition, forecast the rain. So if you want to forecast the rain, you can see that rain depends upon a number of parameters. So the weather conditions and so humidity and a number of parameters are there. So that depends upon, that varies from location to location. Here, the situation in Kerala may not be the same as that in Assam. It may not be the same as in Delhi. You can see that as a country of diversified nature, you can see that our country is in fact not homogeneous in nature, and the tropical conditions are very far from extremes in some situations. So you may have to look for you may have to make predictions on the amount of rains, and the prediction should be as closer to the reality. As you can see that some extremal events, some pieces happen. So, for example, last year we have flood. The year before that we have flood. So, if we can see this one or foresee this one, we may be able to take the remedial measures so that the affected patients will be very less in it. So recently we have in Orissa, we have the Fani cyclone has came, and you can see that about 10 lakh people were in fact separated from isolated from their places to distinct places, so that the life harm was very less, about 4 persons or so. How you did these things? How we can do these things? We can do these things through what is known as the mathematical modeling. What do you mean by mathematical modeling? So based on the data set and based on the parameters that are available, you may have to identify. So in the case that I was pointing out, we may have to identify what are the parameters that really affects the raining pattern in, for example, in Kerala. If you may be able to identify the parameters that are affecting, the factors that are affecting the raining pattern in Kerala appropriately, and if you may be able to build up a mathematical model for that, based on that, you may be able to forecast it, and you may be able to forecast that and give directions to the agricultures and the persons who are depending upon the weather conditions. So these are the things that are going to happen, and you may have to take these measures for precautions, and these are the times for you to make your cultivations or make your farming and all that. Correct? So, or another ways, we have to say the farmer, the agriculture laborers, the agriculture farmers would always like to have forecast of weather conditions and the probability of rain. They need that. So, how we can use statistics here? The answer is by forecasting the future values regarding the weather and raining using statistical models. We may have to forecast the amount of rain using statistical models. So you can see that for this, one should be aware of the certain parameters like temperature, pressure, humidity, etc. Is that right? So if you have your weather conditions or the amount of rain, depend upon the factors temperature, pressure, humidity, etc. But the amount of dependence may be lesser. You do not know. The temperature may contribute about 50%. Pressure may contribute about 20%. Humidity may contribute about 1%. You may have to estimate this. How you estimate it? From the data set that you have. So from the data, from the previous year's data set, you may identify what are the factors that are affecting the weather conditions of the rain. And once you are through, then you may be able to build a mathematical equation or what is known as a mathematical model for that. What is a model? It should be what is a model? A model should be closer to reality. If you have a house and if you are a model for your house, before constructing the house, you may build some model or you may build some, you may do some plans. The engineer will come, he will give a plan to you. What is a plan or what is a model? It is a model for the house. That is, once the house is built, it should be like that. This. So you may have to find a model for your weather. So that it can predict the future, but exactly closer to the reality. There may be long-term predictions and short-term predictions. So now it is raining. Now what is the amount of rain in the next 2 hours? What is the amount of wind? What is the amount of windstorm in the next conditions? If you are looking for the Western countries and all that, you can see that this is very important. You may not, you should be aware of this, the wind velocity, wind speed, etc. before going on. Otherwise, you may be in trouble. Here we can use of time series modeling and regression techniques to make predictions for the development of agriculture sector. So we may be able to use time series modeling and what is time series modeling? If you look for the price of a commodity, you can see that the price of a commodity, you can see, for example, price of rice you are looking for. You can look at the price of rice in the year 2000, 2001, 2002, and so on. You can see that there is some type of pattern. It may be either increasing or decreasing. And in the case of rice, you can see that it is in fact increasing nature. So, or in other words, the current price depends upon the previous price. So, or in other words, you may not be able to see that the price has changed. It has a slow and steady increase, or some pattern is there, or some dependency structure among the data set we may be able to identify. So such a data set we may call it as a time series. So time series, in the time series, the successive observations are in fact dependent. If you are looking for the sale of a commodity, you can see that it depends. It keeps the price of gold, and the price of rice, or price of another commodity. Everything you can see that it varies with respect to time. So you may not be able to. So you can hide. You may have to model this type of data through a particular branch, what is known as the time series. So the time series branch is needed for analysis of that. And also, if you are looking for the regression techniques that I have mentioned, that is, if you are looking for the weather conditions or the amount of rain, there are some factors is there. In Kerala, there are some factors that is affecting the rain. The same factors may not be the ones that are affecting in Delhi. The same factors are not affecting in Assam, and so it depends upon it. It varies from place to place, and the contribution of individual component here. For example, humidity may contribute 50%, whereas in Delhi it may be 90%, or in Assam it may be 10%, and so. So you may have to, once you may be able to estimate it based on the data, then only you may be able to predict the future. So we may be able to know that. So for that you may use the statistical technique, what we may call it as the regression technique. Regression technique, we will identify what are the variables that are relevant and what are the variables that are irrelevant, and what are the variables that are closely related, and what are the variables that are distinctly related. So that in fact measures through your regression technique. That regression technique will tell you that what are the relevant variables that we need to take in. And now, if you look for the percentage income and percentage taxation, you can see that if you go for some surveys, you can see that if you ask a question to somebody, the person will be, what is your income? You say, I do not have any income. I have no employment. But the person may be in Gulf for the last 30 years, and he has earned a lot, and he has some agricultural lands are there. He has a car, and everything is there, and so. But when you ask him what is your income, he says that his annual income is about 10,000. So based on that, if you can see that if you calculate the tax, you can see that the government of India, the governments are depending upon creating their income. One way is nothing but it is through taxation. And if an eligible person who is bound to give tax is may not expose too much, the government will have so many losses there. So based on, so what we will do, we will look at his visible expenditures and his visible, how many house he has, what is the area of house he has, what is his income, how many car he has, whether he is going for foreign visits regularly, and based on these so many factors which are related to him, you may be able to quantify what is his income. And based on that, you may be able to impose tax. So that is what we may usually use, that is the government usually use. Here the statisticians have succeeded in conducting a sample survey and have established the relationship between income and tax levy. So these incomes are the percentage incomes, and tax is imposed upon these percentage taxation. Tax imposed is called the percentage taxation. Such percentage taxation is possible only because of the statistical approach of the sample survey. Using the sample surveys, and based on these, the parameters that we will look into, based on that we will be able to identify the amount of income, his actual income. That is now what happens if a person doesn't show his actual income? How will you find his percentage income? So there are certain visible expenditures of affluent sections of the society. For example, there are large electricity bills for full flats, extravagant expenditure on telephone, foreign tours, and families' expenditure are low. On the basis of these visible expenditures, one may be able to identify, estimate the incomes. Here again, a number of studies have been made to establish the relationship between such expenditures and income. Now let me look for the power sector. That is another area whether we people are also interested. Whether is the statistics or model building has a role in this. How does statistics contribute in power sector? By statistical surveys and analysis of past data, a statistician can project realistic values of the power generation and the consumption in the country. This can be done through different techniques of time series that I have already told. Once the values are projected, an estimate of additional power generated to be calculated. You may have to estimate the additional amount of additional powers to be generated. You may have to estimate the amount of additional powers to be generated. Additional powers to be generated by statistical surveys and analysis of past data. A statistician can project realistic values about the power generation and consumption in the country. So based on the different techniques, we may be able to project the consumers' demands of the power even with a lower target of power generation. So why this is not happening? Because the data clearly indicates that whenever there is power consumption, there is a lot of imbalance between the peak loading power and non-peak loading power. If you are looking for the power consumed in the peak hours and the power consuming in the non-peak hours, and you can see that there may be a direct disparity between the power consumed in the peak hours and non-peak hours. And if you may have to build up a policy in such a way that the system should have power should be generated so as to maintain the needful power in these two situations. That can be corrected with a rational tariff structure so that the consumer's demand can be met with lower targets of power generation. The statistical methods can play a role in fixing an adequate tariff structure. So that is needed. And also you can see that if you look for in Kerala, you can see that if you are looking for the power sector, you can see that the Kerala is divided into different zonal regions, and in each and every region they are collecting the every day, every hour they are collecting the amount of power that are used. And based on that, once the data is available, you may be able to identify what are the peak hours and whether the peak hours is it increased. Earlier it was from 6 to 8 or some time. Now it is 6 to 10. So it is going on increasing. So how we may be able to meet the demand based on that. And the other area that we may have to look for is that the budget. So we have, as you know, the country has what is known as the 5-year plan. For the entire 5-year plan, we have the 13th plan here from 2017 to 22. And for the entire 5-year plan, there is a projection of certain plan size and also the gross budgetary support. So how is the decision of dividing the gross amount to different years in these 5 years data? So there is one important matter where statistical science can help. This has been worked out statistically that in the first year of the plan, the budgetary support will be 16%, next year it is, etc. In the fourth year it will be 22%, and in the final year it will be 24%. That is what we may usually use. But in sometimes this formula doesn't work, and And also there are some other ways, some variations. For example, nowadays we have the COVID and all that, and you can see that most of the government departments, even though they have the fund, they may not be able to use it in correct time. So you may have to make some reappropriations so that the amount to be met, their demand should be met at later time. So that even though you are fixing it from the beginning, you are fixing it at 16, 22, 24, etc., you may have to reformulate it in such a way as to meet the demands. And you can see that our priority will, in fact, changes from time to time. Suppose if there is a cyclone comes, you may have to concentrate more money to that. Suppose there is a flood comes, the government will have to spend more amount to that. Suppose there is an infectious disease comes, government will have to spend a lot of time, lot of expenditure to the health sector, and so you may have to reallocate it. How will you reallocate this? So all those things we will do with the help of statistical models. Now, another area that we may have to look for is how the classification of a country is made. That is, how you classify your nature as a nation as developed nation, developing nation, or underdeveloping nation. Thus, statistics have a role in doing this. Yes, exactly, statistics has a role in doing this. How we will do it? So, we will make use of what is known the GDP. The GDP is calculated using statistical techniques, since this growth rate is not independent of other statistical data. So it is dependent upon domestic savings rates as a percentage of GDP, the current account of deficit as a percent of GDP, and also the ICOR. So therefore, statistics helps one to develop the relationship between these parameters and predict the GDP. And based on that, you may be able to look for the current status of your nation in comparison with other people. And now, this is the global sector that is I have pointed out whether some areas where the statistics is of use. That is, now let me look for the planning activities and planning and implementation activities at the state level. So, Kerala is one of the states having a well-organized statistical system. And the Directorate of Economics and Statistics, or the Department of Economics and Statistics, Government of Kerala. The website I have given is the nerve center of the state statistical system. It is in fact the nerve center of the statistical system. It is responsible for the systematic collection, compilation, analysis, objective interpretation and dissemination of statistics relating to various sectors of the Kerala economy. Now, besides this, whether the Directorate of Economics and Statistics, they have the district office, that is in fact 14 district offices and 61 statistical officers, and they are the places, those are the places where we will collect the data, compile the data, and analyze the data so as to arrive at the conclusion. You can see that there are district levels, the Taluk statistical offices are there, district statistical offices are there, and in the Taluk statistical office there are some investigators are there, and they are the ones they are collecting the data. If government has a problem, and if you may have the price of the crop in a particular place is spoiled due to some reasons. Is it correct or not? How the government will measure it? How will the government will analyze it and whether find it is correct or not? So they are doing this through these Taluk statistical officers and with the help of these investigators. So suppose somebody wants to know how many home nation centers are in Malappuram district. So the Malappuram district has a well-defined and well-versed district statistical office, and under it it has the state statistical value statistical office, and under it there were a lot of investigators. These investigators are employed time to time to get the data and updating the data. That's right. If you are looking for the radio and other mechanism, you can see that these types of informations, that is the, we can see the what is the commercial price of rice in this day, in this market, that market, etc. All these things we will get with the help of these the offices, district level and talent level statistical offices, and you can see that it functions very well at the state level. And the functioning of these things you can see from the website that I have already displayed here. The statistical system of Kerala also includes the various statistical cells involving 41 departments of the state government. You can see that in the 41, for example, we have the agriculture ministry, we have the animal husbandry ministry, health ministry, and so education ministry. In each and every one, you can see that the one statistical cell is there. And the statistical cell is the one that is in fact responsible for coordinating the statistical activities and the data activities there. It has a role there, with a major role there. And now we will go for, as you know, we have a state planning. Whether it has a role in implementing or in coordinating these statistical activities. Now, the Kerala State Planning Board, it is an advisory board which assists the state government in formulating a development plan based on the scientific assessment of the resources available to the state. You can see that you can look at the economic reviews that are available in the website, and you can see that what is the contribution of the planning board and how it is working and so on. The board, if you look at the state planning board, you can see that it has mainly 8 important divisions. That is, one is the plan coordination division, agriculture division, evaluation division, social service division, industry and infrastructure division, decentralized planning division, prospective planning division, and information technology. So these things are responsible for coordinating various types of activities within the state that I will explain. The continuous assessment of the progress of the state economy, its prospects and problems, and suggest reforms and changes in policies, priorities, and programs as may be necessary, which is done by the state planning board. And you see that is how we are in fact familiar. We are in fact appreciated with what is known as the Kerala model, and so these are done. We could be able to achieve through the activities of the planning board in a successful way. Planning and implementing the activities in a successful way. Suggestions on all economic and development policy matters and on individual projects, programs and schemes, and the planning board suggests measures for improving the performance of public enterprises with a special concern for enhancing the quality of service to people, productivity, and generation of surplus for development. And you know, now we have the decentralized planning, that is, you have the panchayat level, and so the decentralized planning and development and its enhancing local and public participation in the projects, and that is in fact monitored by the state planning board. Undertaking the studies, surveys, and researches, as may be necessary for the proper discharge of the functions through the task forces, expert committees, and working groups, which include eminent research institutions and consultants. So, also, the planning board is responsible for the economic review of the state for every year. And if you look at the site, www.spd.kerala.gov.in, you can see that the economic reviews are available in the site from the year 1959 on. And you just try to read it, and you just look at the priorities that government gives from time to time and how it is increasing. So So that will give you a status of how the statistics and planning works very well in our state. Formulation of 5-year and annual plans of the state and monitor and evaluation of their implementation. 5-year plan incorporates almost every field as possible. All those things are done by this state planning board. Very detailed data collection, analysis, and interpretations are involved in the plan. Details of the plan in the 13th 5-year plan. We have the 13th 5-year plan. If you look for the major fields of investigation or consideration in that is the education sector, health sector, labor and labor welfare, gender equality and their development, scheduled castes and scheduled tribes, social services and social security, housing conditions of individuals, drinking water conditions and sanitation facilities of the individuals and houses, food and civil supplies of the state, absolute poverty of the statistics for development, how it can be eradicated and all that, how agriculture sector, how it is going on, and what are the programs to be implemented in the agriculture sector, what are the programs to be incorporated in the industrial sector, that is the small scale industry, which type of project I may how to take care of, and in the large scale industry, what I may have to promote, and so on. And in science and technology, what are the priority areas that I may have to concentrate? And information technology, what I may have to take in care of, and all those things. All those things are done by the Kerala State Planning Board. And now, there are so many other areas of employment. Now, in this type of employment that we may have to go for, what type of education that I may have to invert the individual, and so that they may be equipped with what type of employment and which type of employment I may have to generate it, and how much of the people are unemployed, how much of the people are underemployed, and so on. We may have to estimate this. So based on that, once you may be able to identify how much of the people are unemployed, you may be able to give some particular training to them so that they may be employed in some sectors. And you can see that in some areas the people are underemployed, and how you may be able to meet the requirements of them. Give promotion facilities so as to how jobs according to their skill and all that. And the transport sector, power and energy sector, irrigation sector, environment, biodiversity, forestry, climate change, disaster management, and so local self-government, tourism, sports and youth affairs, art and culture, NORCA, non-resident Keralites affairs, resource estimation, evaluation of projects and skills. In each and everything, you may have to make new schemes, and how you may make new schemes based on the data and based on the progress we may have to formulate the future. So all those things we may be able to do with the help of modeling, that is statistical modeling. So, or in other words, for planning and proper planning and development of a society, the statistics is an inevitable thing. Now, may I continue, or at what time I can continue?
Sir, you can take 10 minutes more. 10 to 15, you may take.
Okay. Now, I will just want to tell the role of mathematics and statistics in formulating these types of investigation planning. What is the role of mathematics and statistics in planning activities in a state? So for that, when we look for mathematics or statistics, we can see that most of the participants have a base on mathematics and some have a base on statistics. You may come across the variability, the various types of models. Some have studies random variables, some have studies the distributions and all that. And whatever be that sophisticated technique that we are studying or we are learning, they are in fact needed for, we are using for, or it should be used for the development of the society. Now, I will explain how the statistics techniques and the mathematical techniques play a role in planning the activities of a state or a country in the areas that we have discussed earlier. So, for that, let me start from the very beginning. What is statistical thinking? What is a variable? And how does one come across a variable? How does one come across a constant? How one come across a random variable? And how one come across a model? And how one come across a statistical model for a mathematics? So that is the way that I want to proceed. And since the time is, then I will look for some applications and how it is essential for studying the different types of distributions and so many things for data modeling. So my aim is to identify or to discuss the role of data modeling in the planning of a particular country. So let me look for variable, that is this very elementary. The successive observations of a system or phenomenon do not produce exactly the same result. Statistical thinking can give us a useful way to incorporate this variability into our decision making process. You can see that if you conduct the same experiment, you have studied you have conducted, if you are students of first group, etc., at the +2 level, you may come across what is one of the resonance column, simple pendulum experiment, and so on. And you can see that if you repeat the experiment, same experiment, the results that you are getting are different. You are doing the experiment in the same conditions, and nobody is compelling you to do the experiment. You are doing by yourself, and no experimental conditions are varying, but still then you are getting different result. And you can see that it is not because of your fault. Why it is? So the statistics gives us framework for describing variability and learning about the potential sources of variability are the most important or which have the greatest impact on the performance of a system. So we must have to identify this. I have told earlier that in some cases, if suppose a person has a heart attack, all of a sudden he has got a heart attack. Immediately he has taken to the hospital. Doctor have given some medicine, and based on that medicine, he will check his conditions. He will check the parameters. He will check his blood pressure, sugar, cholesterol, and everything. And he will say that if he finds that someone is very much varying, he gives the medicine to make it stable. Right. So even though the medicine is applied, he is not getting QA, which means that the medicine he has applied is not proper. So through trial and error, he is arriving at the conclusion. he is not arriving at the conclusion, not all on a sudden. Based on the so many medical equipments and medical technology, and based on his wisdom, he is arriving at the decision. So there are so many parameters of which one are dominant, and one of the dominant factor which prevails at present may be the one that has caused the disease. All on a sudden. So you may have to identify that factor. So all those things we may have to take into account. And let me look for another example. Suppose that an engineer is designing a nylon connector to be used an automotive engine application. So his aim is to design the connector in such a way that it will produce the pull-off force, exact pull-off force. And for that, he has produced 8 prototypes. Prototypes means that the things that are came from the same manufacturing process, and 8 units are produced. And then he has checked what is the pull-up forces measured by these prototypes. And in the first one it is 12.6, second one it is 12.9, the third one it is 13.4, fourth one it is 12.3, and so on. Which means that he has produced the prototypes of the exactly the same unit. Same thing, he has got different pull-up forces. Why is so? So we say that there is a variability in the pull-up force measurements, and because the pull-up force measurements exhibit variability, and so we consider the force to be a random variable. So you can see that, exactly the exact measurement may be 12, but in the first time you let it be 30. The exact measurement let it be 30. In the first time you have got it as 12.6, means that it is minus 0.4 from the reality. And in the next time it was minus 0.1 from the reality. Again it is plus 0.4. Again it is minus 0.7. Again it is 0.6. Again it is plus 0.5. And so you have done the same experiment, you have repeated it, and in the based on the same equipment you have produced the items, but you are getting different pull-up forces. So, or in other words, I have my exact measurement, the measurement that I have to obtain was mu. That is, but in my case, it is 12. It is 30. In my case, it is 30. Exact measurement that I expect from the 8 prototype units that I produced is 30. But the first one gave it as 12.6, the second one gave it as 12.9, and so on. So which means that there was some amount of random disturbances. That disturbance made the exact value, made the observed value distinct from the exact value. Right. So in the first case, that is the observed, your observed value is X, and the value you have to obtain accurately was mu. So you have, there is an amount of random disturbances there. The constant remains the same with every measurement. That is, the mu remains with every measurement. That is my constant. Mu remains with the constant through every measurement. But there is a small change in the environment or the test equipment or the difference in individual parts themselves and so on forth. That will change the value of epsilon, and that will result in a change in X. So if there were no disturbances, epsilon should always be 0 and X should always be equal to mu. Right. So, however, this never happens in the real world. So, the actual measurements X exhibit a variability. If you are looking for the weight of you or a height of a person, you can see that if you give the measurement, that may not be exactly the correct one. We may often need to describe or quantify and ultimately reduce the variability. That is the role of a statistician or a scientist. See, the role of a scientist is that the scientist will have to describe the forthcoming situations closer to the reality. So or in other words, if you take part your mu from there, you may get your epsilon. And epsilon in the first case in the example, what is it? The first case it is minus 0.4, second case it is minus 0.1, third it is 0.4, the fourth one it is minus 0.7, 0.6, 0.5, minus 0.4 and 0.1. Right. So that is a variable that varies random. And now what are the possible models for, so you have some types of variables. If you are looking for the height and weight of a person, you can see that there may be some amount of relationship between them. If you are looking for some factors there, that is the income of a person, the income of a person may be from income from different sources. So the ultimate income he has is a linear combination, or it may be a function of the income from various sources, and so there may be a linear model, or a quadratic model, or a cubic model, or exponential model, or a logistic model, or a growth model. We have studied all those things from our very beginning, from our elementary classes from 8, 9, 10 or onwards. And we have seen that what are the equation of a straight line, from the, what when you have studied analytical geometry, you have studied the equation of a straight line. So you can see that somehow you may be able to make it in the term y equal to a plus bx, and you may be able to use the usual curve fitting techniques to estimate the values of a and b. Similarly, for you may be able to, based on the data set on x and y, you may be able to find, estimate the values of a, b, and c. And if you look at this one, how does this vary? Just look at this. This I have taken a is equal to 1, B is equal to 2, C is equal to 3, and then I have taken K as 4. I have D also. Yeah, D also. I have taken A as 1, B is equal to 2, C is equal to 3, D is equal to 4, and K is equal to 5. And this, let me look for what is the I have calculated the values that you class in your calculate your elementary classrooms, and if you just look for this equation, you can see that it is a straight line that you expect that it is a straight line. Then just you have the quadratic, you have there is a slight there. And if you have going for the third degree, there is slight model. If you are looking for the exponential one, there is slight model. When this. And if you are looking for the logistic growth model, you have the reverse when this. And if you are looking for the logarithmic one, you can see that this is indistinguishable. Right? These two are, since this is a particular case, these two are somewhat like. Right? So these are in fact the types of this. Suppose you have a data set. Data set, you may have to model means that you may have to find the appropriate mathematical equation that has the capability to describe the data set correctly. So that is what you may call it as the mathematical model governing a data set. A data set is in fact a realization of a particular phenomenon. Right. So if you have the price of a commodity for the years 1980 to 2000, or 1980 to 2019, so right, for the last 29 years or 30 years, whatever it is, you have that one. If you plot that the price years along the x-axis and the price along the y-axis, and you find plot a frequency curve or a curve one, you may be able to see that one you may call it as the data. That is the plot for your data. That you may not be able to approximate by a mathematical equation always in such a way that it is closer to the one of the equations that I have described here. So if you may be able to identify a mathematical equation, so that all the data points that you have described in the price data will lie on it. It exactly describes it exactly coincides with or it exactly able to predict the future correctly. Right. So, and you can see that it is not possible otherwise. So now let me look for some examples. Now let me look for some exercise that I did earlier. That based on a tourist data. Yeah, it is nothing but it is the number of tourist arrivals from the selected countries, example UK, France, Maldives, USA, Germany, and Australia. I have the data set. That is the number of tourist arrivals, number of tourist arrivals from the year 1992 to 2007 from the country UK, France, Maldives, USA, Germany, and Australia. And I may have to identify how many persons, how many persons will come from UK will come to Kerala in the year 2020. How many persons from UK will come to Kerala in the year 2022 itself? Right. So that is my aim. And I may have to identify based on the data set that I have, that is the number of tourist arrivals from the year 1998 to 2007 in the country, from the country France, how many, based on that data, how many people from France will arrive to Kerala in the year 2021, 2022 and so. How I will do that? If I can do it correctly, I can tell the policy makers or the state government can make the measures to entertain them correctly in a proper manner so that to meet their demands, give them hotel accommodation, give the food according to their satisfaction and everything so that we may gain more and more foreign currency and so on. Or as a policy maker, the tourism department may be interested in the number of tourist arrivals. And as a statistician or a mathematician, whether I may be able to contribute anything to this. How, as a mathematician or a statistician, I will contribute to this? That is my question. So how will you proceed? Right. So using this model, we may be able to predict the number of tourist arrivals. And what we have did is that we have attempted that how many variables we have? We have two variables. One is the year and the other one is the number of tourist arrivals in a country, for example. So I have X and Y. And I may be able to identify a relationship between X and Y. And the relationship between X and Y should be identified in such a way that it should be closer to the reality that it can explain the nature of tourist arrivals in the coming years in a very clear and a very satisfactory manner. So for that, I have tried the models, linear model, logistic model, logarithmic model, quadratic model, cubic model, and exponential model for the number of tourist arrivals. And then for each model, I have identified what is known as the quantity, I will call it as the coefficient of determination. That is, in statistical terms, our R square. What is R square? R square is the proportion of the variance in the dependent variable that is predictable from the independent variable. The proportion of the variance in the dependent variable that is predictable from the independent variable. Or in other words, how the R square will measure, how we may be able to identify the variability within the data set, within the data set. If R square is higher, what does it mean? That model can clearly explain the variability between the independent variable and the dependent variable. That is the number of tourist arrivals from a particular country with respect to the India. So, or in other words, it provides a measure of how well observed outcomes are replicated by the model based on the proportion of total variation of outcome explained by the model. And the model with the largest R square, I will call it as the best. Right. So for the UK, if you do that one, you can see that the R square is large. I have tried with all the models. What are the models that I have? I have the linear model, quadratic model, cubic model, then exponential model, logarithmic model, logistic model. And I have computed R square for each and every one. And I have found that the R square is larger for this model, that is the cubic model. And this is the model, that is the one that is able to predict the number of tourist arrivals in UK. And we see that the same model is not able to predict the number of tourist arrivals in France. So because the data set is different, and you can see that the number of tourist arrivals from UK and US, France are very entirely different, and you may be able to predict the number of tourist arrivals in France based on this mathematical equation that you may call it as a model. That is how we may arrive at a model from a given data set. Right. Let me with this one. Let me stop here. And if I have so many things to talk about distributions and everything, but the time is short. I am not going on the details, but I will just show you some slides that I have done that will this time will just show you. So these are some of the things. And if you look for some distributions, now based on this, so based on the mathematics of the R square, you may be able to predict it. Now the next is okay. Now how will you come to the distribution of it? Is it necessary for one to know about the distribution of it? If you are teaching a student statistics, or if you happen to teach a student statistics, so the student will have to, you will teach him binomial distribution, Poisson distribution, then hypergeometric distribution, geometric distribution, negative binomial distribution, and so on. And so the student may naturally ask, if there is only one distribution, and it can have the capability to explain all those things, then I am very happy that I may have to study only one distribution. Right. So, or in other words, if you are looking for the continuous data set, you may have to come across the normal distribution is there, Laplace distribution is there, exponential is there, gamma is there, variable is there, lot and lot distributions is there. So, my question is, or a promising student may ask whether he needs to study all those things, or what is the essentiality of studying all these distributions. What is the essentiality of studying all the distributions in his course? So, or in other words, how will you come across distribution from a data set? What do you mean by distribution? What is a distribution? Distribution is nothing but if I have 10 students and I have 5 chocolates, I may be able to distribute it in a number of manners. You have studied permutation and combinations, and you may be able to distribute these things among these chocolates among 10 students. And how many if I may have 10 chocolates and 10 students, you may be able to distribute it. One way is that you can give each and every one one third. That is one possibility. The next possibility is I will identify two best students in the class and I will give each both of them 5 each, and all the rest I am giving 0. That is again a distribution. Now the third one is that I will go for the students who are very poor in the class, identify 5 poor students in the class, and I will give these 2 each to all the 5 poor students. So these are all distributions. So what does the distribution of the data set means? So you will have to identify. I am just talking. I am not going into the details. If you look into the inside, if you have an insight on distribution of the data set, you may be able to know more on that. And you can see that the figure I am showing here is in fact a left skewed data set, and this one is skewed one, left, and what is this? This is a right skewed data set, and this is a data set you may not be able to tell it is a skewed one or a non-skewed one, and so on. And so, if you are looking in our classroom, we will teach normal distribution with we will say that it has so many characters. It is good for this one. The height of the student, you may be able to model with this one. You may be able to model the income by this one, and so on. So, what, if you are going into the details of it, you can see that if you are telling that the distribution is normal, the standard normal, it means that a lot of things. Which means that if your distribution is normal, you can see that it's standard normal. This, what does it mean? It means that its mean is 0, standard deviation is 1, and in the interval -1 and 1, it will contain 68% of the data set, and which means that from -1 to 0, we have 34% of the data set, and 0 to 1, we have 34% of data set, and between 1 and 2, you have about 95 minus 68 by 2% of data, and so on. So, by a statement that your data is normal, it may communicate a lot of things, and you may be able to apply the normal distribution only when your data set satisfies all these things. Otherwise, you may not be able to identify. How will you arrive at a data distribution from a data set that you have studied from your 11th class? Anyway, that will in fact give you some of the intuitions and why we may be able to look for more and more distributions and more and more understanding of the real data sets and the analysis techniques of data sets. With this, I will let me stop. And any questions or clarifications, please ask. Question? Any questions or clarifications?
I invite the participants to interact with the resource person if they have any doubts or clarifications in the presentation. Thank you, sir, for the wonderful and fruitful session. It was really rich and prolific with ideas and concepts. Thank you once again. One important announcement. The certificate will be provided to the participants through the feedback link in the description box of the video in our YouTube channel, Little Flower College. I repeat, the certificate will be provided to the participant through the feedback link in the description box of the video in our YouTube channel, Little Flower College. Let's move on to the final stage of our webinar. I invite Dr. Mariama Anthony, Assistant Professor in Statistics, to express the words of gratitude.
Good afternoon, one and all. Today, Statistical Fraternity is celebrating National Statistics Day with a variety of programs throughout India. I am extremely delighted that we were able to conduct a webinar in this context. Coming to the winding up session of the webinar, Statistics for Planning and Development, we, the family members of Little Flower College, Guruvayoor, express our sincere thanks to Dr. K. Jayakumar, accepted our invitation and shared his views and academic excellence to us. We were able to have knowledge about the various statistical systems and their roles in planning and development. Thank you very much, sir. Now, I wish to thank our principal, Reverend Dr. Sister Valsa MA, for the constant inspiration and support given to us in the conduct of this webinar. Thank you, sister. I am thankful to the HOD Ms. Alfie Jose and all other faculty members of Mathematics Department for their support in conducting this webinar. Dear participants, hope that this webinar was fruitful to you. On behalf of Mathematics and Statistics Departments, I express my sincere gratitude to all the participants. Now, a big thanks to Mr. Bush Andis for his technical support. From the bottom of my heart, I thank God Almighty. Without His grace, this event would not have been possible. Once again, thank you all.
Thank you, Miss, for those good words. Thanking you all. Have a nice day.
Thank you, sir.
Thank you, sir.
I will.